Let me just introduce myself. My name is Banjo Obayomi. As Victoria said, I also run a data ops meetup. It's focused on the DevOps side of data and how we can integrate those two. I work at 26 Labs as a software engineer, doing a lot of cool productization of machine learning models. So how do you take a machine learning model and make a product out of that? A lot of cool work. And it kind of inspired me to make this, knowledge graph creation using Grakn.ai. Now I'll walk through how I went through this process. Let's see. So back in the day when we can all attend large conference halls, I went to this conference called AWS VMARS, and something struck me there. They talked about Warren Vogel, the CTO of Amazon, went up on stage and talked about the history of AWS, how they started with 3 services in 2006, storage, compute, and database. And then he fast forwarded to 2019 when they have over 150 services, compute, database, analytics, AI. It does seem like so many things together. How do each of these components work by themselves? How do they work integrated with other themes? How do you build scalable apps? How do we use kind of our DevOps mindset to connect all of these different services to make products? So it really got me thinking, like, how are all of these services connected? How does S3 relate to EC2? How does Lambda relate to a Lustre or ESCS? All these different components thrown together, how are they connected? So this made me to look up a knowledge graph. So when people think of knowledge graphs, they think of entities that are connected to each other and cool graphs and lots of different nodes and links and spanning edges and like, oh, this is cool. So what if we try to make a knowledge graph using AWS? How would that look like? How would you even get started with that? But first of all, like, what exactly is a knowledge graph? So pretty much a knowledge graph encodes relationships between entities. So I talked about how does EC2 connect with S3. So what's that relationship like? How do you define that? What is it? And what is an entity? So in our case, like an AWS service is an entity and a relationship is how it's being used. So in that, I started to look at a tool called Grakn.ai. So what Grakn.ai does, it allows you to create knowledge graphs. So in this example here, we basically have, on the left side, we have kind of like a schema language where we're actually defining what our knowledge graph is. So here I'm just defining an entity. An entity has a name, a description, service description, URL, and then it plays these 2 roles. So a relationship is a role. So in this simple example, I have 2 roles, linked and linker. So a service is linked to another service. So like EC2 is linked to S3 and S3 is linked to EC2. And that has a detail string. And then you can visualize that kind of relationship here. And imagine you could have multiple things spawning, multiple entities, multiple relationships, but in true DevOps fashion, we want to scale it up slowly. So I wanted to understand what's the simplest knowledge graph I can create from using entities and relationships and having an AWS service from the service name description and some information about that. But in order to do that, I actually needed to get all the product information. So if you go to amazon.com/products, you see all of these different type of products that I have from like game tech, end user computer, media server, robotics, quantum technologies. Like there's just so many things. So how can I create a knowledge graph? I don't want to manually insert all of this information. So we needed a way to kind of grab all this information and insert it into a knowledge graph. So that's kind of the purpose of how do I create this automated knowledge graph without having to manually insert each of these things. So what I mainly had to do is I had to make that schema. I had to define what I want to do. So another way to think of this is an ontology. How do I structure unstructured data? So I'm making a structure here, and then I'm going to put all that data into this ontology so it could be rendered in a knowledge graph format. So I use scraping, web scraping. So I used a library called Beautiful Soup. And pretty simple. I point the HTML parser to the web page, and then I have to manually go through and actually see, okay, how is this page structured? And it has a very simple layout. It has like a class that encodes all the information, and I can kind of iterate through that class there, and then I can easily strip out information. So I can get the type of service, like is it a machine learning, game tech, the URL that it's pointing to, the description for that, and then the name. So that's kind of that basic metadata that was created from the unstructured data and putting it into my ontology for my knowledge graph. So I can get all that product information, but I can't really get the relationships from that. So that kind of was my second biggest question. Okay, I get all the products, I can put it in a knowledge graph, but how do I make that second thing, the relationships? I can get all this service, but how do I get this linked and linker? How do I say this service is linked to that? Just because I got the metadata, I don't really have any intuition on how these products are linked. And this is kind of the point of the knowledge graph. You have no relationships. There's no point of doing a knowledge graph. You can use a regular database. So this is kind of the meat of getting an ontology and knowledge graph, is how each of these entities related to each other. If you think of it like a normal SQL database, you would have join tables, and like this table joins to this table, and you're pointing this record to this. And that can get confusing and complicated when you have lots of different elements. People always cringe when they have multiple joins. You have to do a left join of this. Knowledge graph kind of removes that by encoding that kind of relationship into the actual entity itself. So the white papers. So Amazon has a lot of different white papers. So white papers are pretty much a standard of a ground truth, if you will, of how they utilize projects together to create bigger applications. How do you connect an EC2 instance and have it talk on S3 bucket, etc. So white papers are the ground truth of how services are built, and it gives you a lot of information on how services are related to each other. So I needed to collect these white papers. So I used a similar fashion of using Beautiful Soup to actually go through and grab each of those white papers. This was a bit more complicated as the structure is a lot different, but it was pretty much the same path. Open that web page, look through the div elements. From there, grab all the unstructured data and structure it. So find the URL, the name, the description, the topic. There's always so with unstructured data, you're always gonna find something that doesn't fit into your exact pattern. So I had the hard-coded element for some topic that I think there was only one of, so it didn't fit in with the main thing. So that's another thing you're going to find in pipelines with data, unstructured data. There's always going to be some outlier, and how do you deal with those outliers and keeping track of those? So this is a one-time thing, but if you're scaling up a pipeline or data ops thing, a DevOps thing, you want to make sure you account for those outliers and have a way to handle them and code and track them. But so when you download a white paper, it's really just a PDF file, a lot of text and information. So again, manually trying to parse that and understand, okay, I'm not going to read every sentence and find every instance of how a service is used or something else. So how can I automate that in a fashion? How can I get this PDF file and then parse the information and then put those relationships from each of the services into a knowledge graph? So the first step of doing this, I needed to get that PDF and turn it into a text file. So there's a cool library called PDF to text. Pretty much, once I had those URLs, I download the white paper. I use PDF text to actually convert the PDF to a text file. And then once to the text file, I can do string operations of that sort and try to find information from that. So that was the first step. And then after we have the text file, so it's a text file that just has a bunch of sentences, I used a framework called Spacey, which gives us a natural language processing model to actually parse sentences and get nouns, verbs, actions, products straight from that. So I can pretty much, once that text is parsed, put the text into a spacey model and extract information from that. So after I created a script to do that, I can find sentences like build Amazon SageMaker notebooks backed by Spark and Amazon EMR. So I can get like the subject is Amazon EMR. I put all my metadata, the time, get snippets, the entity. And so how I define relationship in this concept, if two products are in the same sentence, that means they must be utilized in some fashion. So here we have like Amazon EMR is connected to Amazon SageMaker, and the sentence that put that in was build Amazon SageMaker notebooks backed by Spark and Amazon EMR. And I get all the metadata, so the URL, the name, description, topic, the date. So building up these connections through looking through all the hundred white papers, what are all the similar connections where two products in the same sentence and how are they linked? So that's how I define link in this situation. I'm not manually going in and say, okay, that's a valid sentence or that's not a valid sentence. I'm just seeing how are these linked to in the product, the actual white paper, how those two products are connected together. So now that we've gotten all this data, we've gotten the product metadata, we've gotten the links of how the products are connected, how do we actually take all these unstructured data and put it into a knowledge graph and to our ontology that we made? So some more complicated code, but it's pretty simple once you break it down. So Grakn had its own query language called Grakn, but basically you have to do this query. You have to get rid of some strings. So HTTPS, I had to get rid of this colon // A lot of special characters break in Grakn, so that's one thing I had to learn the hard way, trying to insert things while by themselves, try to escape strings. A lot of things, a lot of edge cases you got to figure out and how to get past those. But once I figured it out, it's similar to like almost like a database. I'm inserting this service. I have all my metadata, the name, description, the URL, the service type. And then that's for the actual entity. And then for the relationship, we want to match. So we want to match the services. So before we had like Amazon EMR, Amazon EC2, match all those services and match the details of what we put in for those products. So all that metadata we got, we are putting it into this GraphQL format and then shoving it into these query statements. And then once you run all these queries, you get something like this. So you see a vast array of dots and lines and services and entities, relationships, all scraped from all the data mining that we did. We were able to create a connected knowledge graph with all the services, the products, and we can see kind of, it's very vast. It's hard to decipher all of that, and if you zoom out a bit, you even see some disconnected services, like I think these were some of the newer services that won't really mention with any of the other older services. So it's really cool how you can, from taking all that unstructured data from HTML parsing, grabbing things randomly and then putting them into an ontology, we're able to create a connected graph, how all the services are connected. And when I broke it down, you see Amazon S3 was the most quoted service, and makes sense. A lot of services utilize that. And if you look through white papers, they always talk about store it in Amazon S3 or do this. I was surprised Lambda was a bit low at 147, but it was really cool to kind of see how which services are used most and referenced the most through the white papers. So a lot of people will ask, like, what can you do for knowledge graph? So it's cool that we put all this data in there. We got all this unstructured data, and now we shoved it into a structured format. So cool. Now, what does the knowledge graph enable us to do? So I'm not sure yet. If you have any suggestions, please reach out to me at Dan's the Man on Twitter. But I have found some things you can do. So a knowledge graph really helps you find linked entities. So we put all these things together. We encoded the relationship to the entities. So how about finding them? Search is a common thing. Google uses knowledge graph for their search engine. So knowledge graphs are used for finding linked entities. So how can we do something similar utilizing that find linked entities action? So one thing I thought about was a quiz. So I got all this information from white papers. If you ever took an AWS certification exam, they always say, read the white paper, read the white paper. But there's not really any like quizzes on like the white paper. I'm not going to read like a 50-page document and just say, okay, that's it. Like, how do I quiz myself? How do I understand what's in this white paper? So doing all this research and development actually gave us a way to actually automatically make quizzes from all the sentences we scraped. So one way I kind of say, oh, we have this knowledge graph. So how can we actually do that? Make a quiz harder. So a lot of the times in AWS quizzes, they always put like a lot of answers that are kind of similar. So I wanted to kind of replicate that by using my knowledge graph powered search to find similar answers. So in this question, it says the most common compute service used in IoT is blank, which allows actions to be invoked with telemetry data reaches AWS IoT Core and AWS IoT Greengrass. So when so how my script worked, it picks the right answer from that's in the sentence. So AWS Lambda in this case. And if I randomly just pick a service, it's gonna pick like random things that have nothing to do with Lambda most of the time. Like has Steep Racer, Redshift, Infrared. But if I use a knowledge graph search, I can see, okay, which are the products that are closely linked to Lambda? So it has step functions, code deploy, VPC. So the more close, what the knowledge graph empowered questions are doing is saying, okay, I know the answer. What are the closest linked things to AWS Lambda? So by doing that, I can find answers that are closely associated with AWS Lambda. So it can really differentiate if you understand what are the different use cases instead of just picking random answers. So using Grakn, we can kind of do that using the find that service and that find the service of the answer. So we pass in the answer AWS Lambda. So basically I want the query saying, okay, get me all the common things that are connected to AWS Lambda. And then from that, pick the other answers from this query instead of randomly picking a random product. So if you want to, you can actually try the quiz. It's online right now. I used Firebase, ironically, to host the quiz. Firebase is another platform operated by Google that allows you to deploy applications. So the idea is you can go to this quiz, it'll generate 10 random questions, and then using that knowledge graph, it will pick some questions here. So if you're feeling fancy or you want to have something to study for your next certification exam, using this knowledge graph powered service, I'm able to generate random questions. And each time you go to it, you get a new quiz. So you can just make sure you understand each of those services and you're prepared to answer any question and take the exam with more confidence. These are some resources of things that I used, Grakn, Spacey. I wrote a blog post about a lot of the techniques I used here. If you actually want to go to Cloud Quiz yourself and try something, my Twitter, and if you are looking for a new job, 26 Labs has some jobs.